Hi, I'm Carl Franklin. Very recently, I had an issue with a piece of gear I use in my band. It's a mixer that we use not only to provide headphone mixes in rehearsal, but also the main mix when we play gigs. I wanted to rearrange the way that the channels were laid out. Channel 1 for guitar, channel 2 for my vocal, that kind of thing. Only the software didn't offer that feature. But I found a way to hack it using my programming skills. And I want to share it with you to encourage you to experiment and try to figure out problems that may seem insurmountable. You're a programmer. You can do it. Hacking black boxes is coming right up on the .NET Show. So we're hacking a black box, and this is it. This is a mixer for live or studio recording that is controlled with an iPad application. It's called the PreSonus RM32AI. It's in the Studio Live series, PreSonus Studio Live RM32AI. I bought this several years ago because I wanted a solution like this. And I'm just going to give you a brief intro to this piece of hardware and the challenges that I face now in using it. So you have 32 inputs. These are standard microphone XLR inputs. You can also plug keyboards and guitars and other things into them, direct outputs from amplifiers, things like that. So this is standard stuff. It also has 16 outputs. And you can control up to 16 auxiliary mixes. So what I do with this in the band is there are connectors in the back, and I have those connectors going to headphone amplifiers. And so each band member is assigned a different output or mix, and they can control that themselves with their iPhones or Android phones on the gig. So there's no monitors on the floor feeding back into the microphones. Everybody's got in-ear monitors or earbuds, and they can pull up their phone and get a free application from PreSonus in the App Store. And they can say, I want a little bit more drums, a little less bass, a little less Carl because he's loud, his guitar. Turn that down a little bit. I want to hear more keyboards, right? I want to hear more of myself. So everybody gets their own personal mix. That is so awesome. And this really helped our band to sound great and to be low maintenance in terms of gear. Now, let me tell you the story of why I need to hack this thing. This software right here that you run on an iPad, there is a Windows version of it. It's called Universal Control. And also, you can run it in demo mode. And this is what it looks like. So before we can use it, you have to set up all the instruments on these channels. And there's 32 channels, and you can see they go all the way from left to right here. Here's 32, that's the last one. So when I started using this, I was in a recording studio in New London, Pop Studios, and we had jacks in the walls. So here's a picture of the recording studio, and this is even before we were finished with it. But notice over here, you've got input jacks, right? And this is over by the guitar station, and the drummer has some over here and some over there. And the ones for the keyboard are behind this rack box, which is my RM32. And you can see headphone jacks right here. So the whole idea was that I wanted the band to be able to practice, and the inputs that they used would be the ones that are closest to them. And admittedly, in this picture, you can only see a couple over here on the wall. But this is typically where I would sit, guitar. Jay, my brother, would be over here with keyboards, bass player over here, and the horns, when they rehearse, they're in front. So that means I wanted to set up the channels so that we would use inputs that are closest to the instruments. So that means channel 25 was the kick drum. And you can do what I'm doing right here. You can just set the name of the channel here, and I can create a little icon here. There's the kick. And for each channel, you have a preamp, which is sort of the main amplifier. And you have a gate and a compressor. And I'm not going to tell you what all these things are. It doesn't matter. You have an equalizer, so it's a full parametric equalizer. So, for example, if I wanted a kick drum, it might look something like that. And you have a limiter. So, I might set up the snare over here. The snare is on channel 26. And the EQ for the snare, I'm going to drop down like 500 hertz because that's typically where the nasty stuff is. Anyway, you get the idea. I have these channels all over the place. And I took a screenshot of what it looks like. And here you can see. Let me zoom in a little bit. So the bass is in 4. I've got the organ left and right in 5 and 6, the piano in 7 and 8. And the horns, it's weird. I have the alto and tenor saxophones over here in 9 and 10. However, the trumpet and bone are in 23 and 24. And also, we have my brother and I vocals in, these channels right here, 13 and 14. But our female vocalist is in 11, and we had to add a drummer vocal, and the only one that was open at the time and near him was 20. Now, this is a problem because when we go to play a gig, and there's a sound man, I hand them the iPad, and they have to figure out where all these channels are, and they're not logically grouped. So to make a short story longer, I moved out of that space, and now we want to reorganize these channels. In other words, I want to start like most studios do with the drums down here, the first 8 or 9. And then I'll add the guitars and the bass and the pianos, the keyboards, the rhythm section. I want all the vocals grouped and I want all the horns grouped. Okay, that sounds like something that you should be able to do with the software. However, you can't. I would just love to be able to drag this. And you can't see this, but I'm holding the mouse down. You can't just swap channels and move them around. So I was facing, for every single channel, I would have to, write down or take a picture of all of the settings. And the EQ settings there's nothing that you can like copy and paste. It's really, really difficult, and it would have been a very tedious task. So what I wanted to do is be able to swap these things, and I was thinking about doing it programmatically. Now, basically, this unit has scenes, and a scene is all of those settings, those channel settings, the EQ settings, the auxiliary settings, and you can store a scene, and it's not letting me do that, of course, because this is a demo, but not only can you store the scenes within the mixer, but you can also store them on the local hard drive. And once I realized that, I went looking, I saved a scene to the local hard drive, and I went looking for it, and I found it, and this is what I found. It's a JSON file. Yes! So I knew once I saw this that I could write a program to turn this into C# classes, manipulate those classes, and then save it out as a new file and load it up into the mixer. But I had a couple of stumbling blocks along the way. So I'm going to recreate that process for you now of how I hacked this black box. First of all, this is a very large file. We have 8,582 lines. I'm going to show you a very cool feature of Visual Studio. And this is Visual Studio 2019, and I'm just creating a .NET 5 console application. So I'm going to add a class, and I'm going to call it my original classes. And yes, I'm going to put all of the classes in here. But here's the thing. I want to not have a class called my original classes, but a namespace. So I'm going to copy this into the clipboard again. Go back here and now check it out. Edit. Paste special. Paste JSON as classes. You see that? It's going to allow me to paste that JSON and it'll create classes from it. Now, the key is I don't understand what these things do. So let's just start looking around. I figured out that line, the line class, represented those channels, the channels across channel 1 through 32. Okay, there's all sorts of other things, but this is the one I was really concerned with the most. So let's press F12 and go take a look at what that is. Yeah, so this is kind of a problem. There is no base class for a channel. Each one has a different class name. So the property names of line are ch1 through ch32. That's logical, right? But the classes themselves are all over the map. They don't make any sense. And that's just the nature of JSON deserialization. There are really no classes. There's just data. So we're getting this ch111, ch23. Doesn't really matter. But be that as it may, every single channel has a different set of data. Now we've turned it into classes so we can manipulate it, but it's really the data that matters. So let's look at channel 111, the class, which is actually channel 1 on the line. All right, this is interesting. I got a username, I got a color, I got a volume, a mute, a pan. Here's a little foreshadowing. Some of these are floats or single precision, and some of them are ints. So let's keep going down here. And now, oh, look at this. Now you remember on each channel you saw the gate, the compressor, the limiter, the EQ, right? So each of these has a different class. So look at gate 21. Okay, that's interesting. That doesn't look like anything that can't be repeated. Let's find gate 22. Same stuff, right? So let's look at channel 23. So this is for channel 2. Much of the same stuff, but now different gates, compressors, limiter, EQ, like the numbers are different. So essentially what I figured out from this little exercise is that there's a lot of duplication. But I started out in earnest just to see if I could load these things up. And here's the first thing that I did. I hard-coded my scene file, which is what I showed you here. I hard-coded the path to that. And I'm just making sure the file exists. And I get the folder and I create an output file name, output.scene. And now I'm reading all the text with system.io file into this string right here, JSON. And now I'm doing a JSON convert on the root object. Now the root object is in my original classes, so I'm going to grab that namespace and use it over here. Now for JSON convert, we have to install Newtonsoft JSON. There we go, install package, find and install latest version. All right, so let's see if we can get to this point. It worked. Let's look at the scene. I'm going to zoom in a little bit here. Here's the line, channel 1 through channel 32. Looks like it's happening. And let's look at channel 4, because that's base. I go down here. Here's my icon ID, guitar is bass. Here's my username, bass. All right, so username, that identifies it in the volume right there. So the next thing I did was write a little method to print out or show or display all of the channel names. There it is right there. So I'm going to pass the scene file in here. and we're going to look at scene.line.channel1.username all the way down through channel 32. And we're just going to print that out to the screen. So let's do that here. And there we go. These are the actual names of all 32 channels. Yes. Now what I actually want to be able to do is swap them. So that's the next step, is to start down the path of how I can swap these channel values and what's in those channels around. So I started with a loop. I'm going to call display, and I'm going to say enter a channel number to swap, enter to quit. Now, of course, because I'm the one that's using this, I'm not concerned about scrubbing the input, making sure that it's correct. I'm just going to be very careful about entering the numbers. So here's my first channel, which is going to be a string, and I'm going to call readLine to get that. And if I just press enter, there's nothing there. I'm going to serialize the object indented, because I don't know if you picked up on this, but looking at the JSON file, these are tabs, and that's kind of ugly. So I want to change those to just indented spaces. And I'm going to write that out and return. Otherwise, I'm going to ask for another channel number to swap it with, and that's my second channel. So let's just make sure that we can do this as is. Let's start with 1 and 4. So first channel is 1, second channel is 4. All right, we'll continue. And I'm just going to press enter. And that's going to write out to the JSON file. And if I look at that JSON file, here it is right there. It's the same data, but now it's much easier to read. And if I load that one back up, it works as well. So I'm happy. I can read in this file, I generated my classes, and I can write the file. Now the only thing left to do is the logic. So let's start with this. I know I'm going to use reflection, right? And I know I want to start with the line. That's what I want to use, because the line, if you remember, is this representation, the 32 channels. That's a great place to start. So I'm getting the type from line, and I've got my property names, first and second, ch1, ch4. And now I'm reading the property info objects from this type with getProperty. Now this will be the channel 1 property, this will be the channel 4 property. Now I need the values of those properties. So here's the first channel object, which I'm getting the value from scene line, that first channel property. Second channel object is the value of channel 4. And now I need the properties of those values, because those are objects. So this guy is going to give me a channel 111 object. This guy is going to give me a channel, what was it, 23? Yeah, a channel 23 object. And this guy is going to give me all the properties of channel 111. This guy is going to give me all the properties of channel 23. Now I'm going to go through those properties, and I'll get the first one and the second one, you know, the one from the first channel, the one from the second channel. And then I'm getting the value of the first and second properties. And if they're not null, I'm going to swap the values. On the second property, I'm going to set the value to the first property's value. And on the first property, I'm going to set the value to the second object's value, effectively swapping them. Now let's just see what happens. See how far we get. All right, I'm going to start with 1 and 4. Again, I'm just going to try to swap something that's close. Object of type system single cannot be converted to type system int32. All right, so now I got my second clue as to what's going on here. Let's look at the property itself and its volume. On channel 111, the volume property is an integer. On channel 23, it's a single. Now, why is that? Well, let's look in the data again. All right, here's line. Here's channel 1. You can see volume is -84. There's no decimal point. And therefore, Visual Studio interpreted this as being an integer. Now, it would be so much easier if there were a base class for all channels and they all had the same types. But the types are inferred for each class. Let's look at channel 4. Here's channel 4. The volume is clearly a decimal. All right. So I knew that I had to do that. And I actually reworked the classes so that we could have base classes. And here's what I ended up with. So I created a channel class that has all of these shared properties. I also changed color from int to long. It was inferred as an int in most of the channels, but when I did set a color, it was a long, and it told me that it was not an integer, so I changed that to long. Then I just changed everything else to a double, because better to be safe than sorry, and it looks like the hardware can interpret any number as a double, so this is where I started. Now notice I don't have these things in the channel base class, but instead, look at this. Here's channel 1 that inherits from channel and all of the stuff that was in there. So if we want to take a look at the original channel 1, here's the original channel 1. I have a gate, a comp, a limit, an EQ, and a filter. Now over here I've got a gate, a comp, a limit, an EQ, and a filter, and there's no numbers. So that's good. And then all of the other ones, I made sure that they were the same. And then I used a formatter to format and sort all of my classes. So I did the same thing with compressors. Here's comp. And since this is just a regular class that doesn't have any other classes as properties, any complex properties, pretty much all of these are just derived from the base class. So here's DCAs, which are the same idea. We don't really talk about those today. Here's my EQs, which are also set up the same way. Filters, same thing. Same with the gates and the limits. And now we've got all the classes that are just hanging out by themselves. Long story short, I had to redo this to get consistency between all the channels and all the compressors and EQs and all that stuff. But yeah, so getting back to the channels, you can see that there are some channels that have a DCA set, right? And some that don't. And that's because there was no setting in that particular channel in the JSON file. But all I would have to do to make that work is just create a new class. I would create DCA 10 or whatever the next one is, and then make a property on that. So that's no big deal. All right, now that I have that, let's change the namespace from my original classes to my new classes. And now let's see what happens. All right, here's 1 and 4. Boom. Now I've got objective type myNewClasses.gate21 cannot be converted to type myNewClassesGate24. All right, so we got through, let's look at channel 111. All right, we got through 21 as a property of channel 111, and now my code is expecting to set the value of one to the value of the other. And it's not going to work because channel 23's gate is called gate 22. In the laws of object-oriented programming, that's not going to work. You can't set a 21 to a 22. You can't set a apple to a person or an orange to a prune or whatever. We have to dive into these and set the properties of the gate from one to the other. So that means I have to expand my logic here a little bit. So down here, where I was just doing my, set this property to that property, now I have to do some special handling for gates, for compressors, for limits, for EQ, and for filter, and for DCA, right? This is the code that I was executing for, simple types. But the complex types, I have to go a level deeper. So that's what I'm doing here. Take a look. So if my property starts with gate, then I'm going to get all the properties on that gate for the first gate and all the properties for the second gate. And I'm going to do the same thing that I did before. I loop through the gate properties. I get the property for the first one, the property for the second one. I get the value for the first one, the value for the second one. And I set the second one to the first value, and I set the first one to the second value. Swap. And then it's just rinse and repeat with comp, limit, and all these other things, and I just named these differently. So now, guess what? It works. So what I would normally do is I want to start with kick, snare, hi-hat, so let's swap 1 and 25. 1 and 25. Boom. So now kick is there. Channel 25 is now channel 1. It works. So if I keep along this line of thinking, I'm going to swap 2 and 26, which is the snare, and that works. And when I'm done, I just press enter, and there you go. So let me show you what it looks like after I'm done with it. I got my kick, my snare, my hi-hat, high tom, mid-tom 2, low tom, overhead left. Then I got the bass. Now I have the organ and the keyboard. I've got a percussion, my guitar, my vocal, Jay's vocal, Nichelle's vocal, Tom's vocal, and look, all the horns are together too. Bone, alto, tenor, and trumpet. And there you go, bone, alto, tenor, trumpet, and then whatever was left over that I'm not using anymore. So that's my story. This is very powerful software, but I couldn't make it do something I really, really needed it to do. And being a programmer collided with being a musician, and I was able to write this software in a couple hours, and the band's happy, the sound guys are happy, everybody's happy. With just a little reflection and some help from Visual Studio and JSON serializing and deserializing, I got it to work. Hey, thanks for watching. Thanks for watching. Please visit blazertrain.com and the .NETshow.com for more great content.